Okay, so this is an answer to January 2013 Ph04 Question 14. Right, so we've got two table tennis balls, M and N, which are on non-conducting threads, and they're hanging from this point P here. And what the question asks us to do is to draw a free body force diagram for the ball M and label the diagram. Okay, so well, what we need to do is the first thing is acting downward. You have the weight of the ball. Always weight. Don't ever use the term gravity because you'll just be marked wrong. Then across this way, now this is the electrostatic repulsive force. So if we call it the repulsive force, then everyone knows exactly what we're talking about. And finally, the thing that keeps it from falling is T, the tension in the rope. Moving on, look at later parts of the question. Just get rid of that one too. Right, show that the tension in one of the threads is about 3 times 10 to the minus 2 newtons. Well, what this is about is trying to use the weight and do a little bit of SOCAT TOA work to find what the tension will be. So if you look at the triangle that's formed, just looking at the 1 by n, then you've got the tension like that. There we are, and that's essentially what we're trying to find out. There's the point P up there, and then this part of the diagram is simply going to be the weight, mg. And just so that we remember, the weight of the ball is 2.7 grams. So knowing that and the fact that this is 35 degrees, we've got an adjacent angle and we've got a hypotenuse. So the sensible thing to do would be to use cos theta, and in this case cos of 35 degrees, is the adjacent, that's the mg bit, divided by the hypotenuse, the tension. So if we rearrange that, the tension is going to be the cos of 35 multiplied by the mass, 2.7 times 10 to the minus 3. I've used standard form there to convert that directly, times by 9.81, and that will give me a tension of more or less what they're looking for. I think it's actually 0.032 newtons, which is pretty much what they're after. Okay, moving down to the next part of the question. Again, let's get rid of that. Right, show that the electrostatic force between the balls is about 2 times 10 to the minus 2 newtons. Now when I first tried to do this, I thought, well, maybe I should use the Coulomb's law to do that. But actually, you don't need to, because you know, if I just repeat myself for a moment, you've just found the tension. You know that's 35 degrees. If I extend that, excuse my diagram, that's the weight of the thing. They're actually asking you to find out this part of the vector. So, or that vector in that diagram. So, one way of doing that, okay, so we know the hypotenuse, we just worked it out at 3 times 10 to the minus 2 newtons. We could actually just use sine theta, so sine of 35 equals the opposite, so if we call that x, and the hypotenuse, well, let's just use the value that they've given, 3 times 10 to the minus 2. and if you rearrange that, so x equals 3 times 10 to the minus 2 times that, then you'll find that you get an answer of 0.0185 newtons, which is, you know, identical to that really. Right, last part, no sorry, last but one part. Now in the last but one part you really do need to use Coulomb's law, so to calculate the charge on each ball. So if I begin by writing down Coulomb's law, now the charge on the balls is exactly the same, so I can use Q squared rather than Q1 Q2 over R squared, and I want Q. Now I would rearrange this. Now I know mathematically a lot of you don't do this, and that's fine, but this is the way I like to work. So if I put my numbers in now, so my force was 2 times 10 to the minus 2 times the square of the separation. Now that was 20.6 centimetres, so that's going to be 0.206. That's going to be squared, so put the whole lot in brackets. And K, you can look that up in the back of the paper, 8.99 times 10 to the 9. And that, by the time you've done the math on that, will end up to be 3.07 times 10 to the minus 7 coulombs. Okay. Final question. Hang on, let's just get rid of what I've just written. There we go. Right, for the final part, state and explain. So you've got two command words here which we have to obey. So firstly I've got to state what happens and then explain what happens. And if I don't do them both, they're not going to give me 2 marks. Okay, so if I begin by stating what's going to happen, well, the first thing that's going to happen is that M and N, they're going to move, hang on, let's get my English correct here, are going to move further apart. Okay, so that's the state part of this. Now notice one is not going to go higher than the other. Can't be done. And why? Because the force on the two of them is the same. Remember Newton's third law. The force is the same on both. There we have it.